not cubed.
Yeah.
Okay, right, so since it's on the outside,
So, vertical dilation.
okay, so we have a vertical dilation. Well, before we get that, is this the only information I have to say about the transformation? Okay, I can include the factor here. So what's this dilation factor? So like what would we be, well, so we're not talking about units, because I guess when we're talking about units, it's like moving 2 units or translating 2 units. But this is, we're multiplying by a factor of what?
4.
Of 4. And Cam, why is it 4?
But 4 is then multiplied times.
Right, because we have a vertical transformation, so we don't have to use the inverse. Okay, and then so, I guess the other thing, does this equation contain a reflection? Because that was the other thing that was written up here. Okay, what would it look like if it did contain a reflection?
It got to be a negative.
Okay, Jay, can you tell me more specifically what about the negative would signify a reflection?
Negative. My bad. It has to be multiplied by a negative number.
Okay, so the negative times x, or having it, the multiplication of the negative is what would cause that reflection. Okay, so what other transformation do I have up here, Eric? Okay, so we have a vertical translation. So Jaden, can you tell me why this is a vertical translation? Okay, so what makes it a translation?
Sorry, y'all.
Okay, so remember, translations are created from what 2 operations?
Addition and subtraction.
Addition and subtraction, and then dilations are created from multiplication. Okay.
And division.
Yes, yep. Multiplication and division, but remember we do use like the multiplicative inverse. Right. Okay, and then let's just go over one more that someone did. Okay, so on this one, let's see, someone wrote horizontal translation left 3 units, and they wrote vertical translation up 7 units. Okay, so let me ask you guys this. We just talked about the operations that create transformations, right? So what did we say created translations? Addition and subtraction. So if I have a translation left 3 units, then I should have some addition or subtraction in front of this 3, right? Is that what I have here? Okay, so what is this 3 doing? Okay, which means I'm going to have what kind of transformation? Okay, so instead of translation, I want to put dilation in, but is it still horizontal?
Yes.
Okay? And then so now that we've changed it from a to a dilation, what's that dilation factor we're using?
When it's horizontal, you got to use the inverse.
Okay, y'all hear that? Right. Okay, when it's the horizontal, you have to use the inverse. So that would be a horizontal dilation by 1/3. So we'd actually be multiplying all those values by 1/3. Okay. Oops. Not sure whose cards these were, but make sure you have your own. Put your name on the note card that you wrote the equation on. So, and then I'll pick them up, and then go ahead and get that practice out that we started yesterday.
I'm about that.
Okay, okay. And we're gonna start working on that number 2. Cause we finished number 1 here yesterday.
You do took the
Deja, I might have to ask Mr. Kitty to print you a new one because I don't see
She
it.
can have mine. You want it?
You need one too, so. But does everyone else have theirs out? Can you look over with,
Whoa.
what's up?
Life would be so much better if you were the teacher.
And he was the
If he just wasn't here, I was out.
he did last talk.
If he just shut the hell up sometimes.
Okay, guys, let's get this practice out.
Hey, I've been on the first one.
Okay, so we're on number 2. Flip to number 2, yep. So that front table, okay, so Nemo, just real quick, we did this.
I want to take a picture.
Okay, so this is what we did yesterday, so that's all we have to do.
We turned these in.
Oh, yeah, let me pick those up from y'all, sorry.
Turn what it is.
The note,
Oh.
not turn it in, we're just picking up the note cards.
I need a. Padding them 16.
It's on
16.
There you go. Hey, you gonna come back like that?
What are you guys doing? That's not doctor.
I'm gonna look at the door to let you go.
It's not milk. Talk about that. Talk about
Okay, so we're starting on number 2.
that. Miss Courtney, how you do that?
Okay,
It's
what
some more of
do
them
I
back
do?
there. It's some more of these back there.
Yes. I'll grab you one of those in a minute, Deja. Okay, guys, so starting on number 2, we're given a few things and we're asked to do some things.
They do it.
Let's do it. Okay, so you're given the equation of a transform function, so you have to make the table for the parent function and then the table for the transform function.
Hey, shut up.
We just Charlie. He said yeah. He said rambling over here.
Okay, are y'all ready?
Red and tomato. Parent function of x equals x squared. Let's do it. I'm ready.
Okay, so we're given the equation where some transformations have been applied, so we have to make the table for the parent function, the table for the transform function, and then we graph both of them on here. And when you're graphing them, so you want to use a different color, like choose a color to use for your parent function, and then choose a different color to use for the transform function, and stick to those colors throughout all 4 of these problems. Do what? Or like there's color, or yeah, there's pencil color somewhere.
Yeah, so I can get it for the color.
Okay, so before we can make, hey, can we just go over these directions so I can let y'all work on this? Okay, so before we make the table for the parent function, what do I even need to know? What is the parent function?
Yo.
Okay. So, Ryan, what's the parent function from this equation? Uh-huh. Okay, so Deja, what do you think about what Ryan said?
X squared.
Okay, so,
Well, f of x equals x squared.
yes, okay, so write it as an equation. Okay, so now that we know what the parent function is, how do I figure out what values I put in this table?
Would be like 0.
What you let
It's the square root of the number in the.
Well, okay, but,
That's not.
okay, that's for the square root. This is a square.
It's square.
You better do
You
that.
gotta, multiply.
Come back now.
I know it.
It's,
Yeah.
Negative
right, okay, so that's how we're gonna get these values, but what values do I put in here?
Negative 2.
0, 1, 0, 2.
Okay, so let's start, Deja just said we should start with -2. Why do you say that, Deja?
I don't know. Looking at the table.
Looking at what table?
This table right here.
So she's,
Oh, yeah, true.
okay, so she's referencing the parent function table that we used in the past, which is completely fine, but I just want y'all to recognize we're starting at this -2.
I thought we started,
I thought it was,
Okay, if your thing was starting at 0, that's 4 when it was the square
no,
root
I
of
ain't
it.
talking about this.
Is that what you're talking about?
No,
What are you talking about?
I
Hey,
ain't
bro,
talking about that.
Okay,
let lock in, cuz.
so if we have,
Alright,
okay, so if these are input values, if I input a -2, what's my y value?
4.
4,
Okay, if I input a -1, what's my y value?
1.
1.
Okay. Okay, so now we have to make the table for the transform function and graph it.
Mm-hmm.
But, so from looking at this equation, what transformations were applied to that?
Fraction of X.
So what transformation is that?
It's
What,
a
what-
Horizontal.
To the right for it.
It's a, yeah.
Okay.
Yeah, to the right for
Okay, so we know-
I didn't get it. My fault.
also guys, hey, go ahead and graph these points on your
Oh,
grid.
yeah, I ain't got that.
I was hot yesterday, Dave.
Go ahead and graph your parent function on the grid.
That was actually anything.
We gotta do the already word.
Yeah, so go ahead and create that first parabola and then we'll kind of talk about the transformation.
I'm at 12. Dave, whoa,
Okay, so from here, we said this is gonna be, a horizontal. Chase, what direction did you say it was gonna
To
go?
the right 4 times.
Yeah.
Horizontal, right, 4 units. Okay,
Mm.
so before you even make the table for this transform function, do you know what those points are gonna be by looking at this graph?
No.
Why not?
I mean,
You should check.
there's X. Actually, the points are just gonna be the same, the X is just gonna be moved over.
Okay, so you get right, which points are gonna be the same, Chase?
The
X,
X, that is,
the
no,
Y
that
values
is,
are the
yeah,
same.
yeah.
Right, so he noticed that those y values are changing, but I'm saying before you, I said, okay, so go ahead and translate this graph over 4 units before you, and then record what the x values are, okay?
So we move all that. 4 units over.
Well, right, because that's what this tells us to do. That's how we get that, that.
it's falls to the right.
Yeah.
Yeah.
On my, I don't say you like to go off the graph.
So, okay, just so you guys, there's gonna be a few problems in here where like our points that we're graphing go like a little bit above or below the graph a little bit. That's not gonna, not on this one, but just in the other ones, it doesn't mean you're wrong or you've done anything wrong, it's just how the graphs are. Oh, Mr. Kitty, we don't have any more practice sheets from yesterday. And Deja needs one.
Yeah, we do.
I just gave the last one to Nemo.
Hey, you should, yo, she said it was right.
Oh, look at the points,
Yeah,
yo.
one last one, y'all
Subtract
go
on
on.
the points.
Okay, so have y'all,
Okay, I'll just press one. X values, yeah.
okay. He's gonna
It's -4.
Record.
Oh, I have that for you. Yes.
Oh, we can shoot it to the right one.
Hold on, I'm coming.
4 plus.
Okay, so make sure, when you're moving them, all the points moved over. So, 4, this one, that was the same. Yeah.
Bring one out too.
I thought you just got one.
I did.
No.
Me.
You just got a coffee.
I messed up.
Don't wait, be getting so hot.
Okay guys, so you should be graphing the transform function and then recording the points in the table. Right, so yeah, so,
It's cold in here.
Complain about it some more, that'll make it better.
What?
He said if you complain about it some more,
wait, what?
that'll make it better.
Are you good? Okay.
I'm sick, man.
I'm gonna drop by myself, but I sworn it was gonna see.
I'm sick.
That's only 68.
Okay,
And I did. It is
so,
First step.
I'm sick, though.
yes.
Raised to the first. That is not good.
Film, do you cut like some of the parts out?
The whole thing.
When I do what?
Film, do you cut some of the parts out?
That's Mr. Kenny filming for like the YouTube. That's not me filming for, because we forgot to film in first and second block this morning, so this is us filming.
Oh, so do you cut out the parts?
And I said no.
Well,
So you're mixing exponential to
we finna be famous.
Yeah.
You don't get no views anyway. You don't get no views anyway. Probably about 2.
Ryan, I'm pretty sure it's an indictment of how hard y'all are willing to work and study, not the videos, because y'all are not putting in the efforts.
Who's that playing with you?
And man, it's weird. It's like you make a joke, but you can't take a joke.
Oh, I can take one.
That's a lie. We just saw
I
it.
just took yours over. You can't take no photos.
I'm not gonna say that I can.
Oh.
Okay,
So,
guys.
see how here I'm repeating.
I think I did right.
Okay, so after you translate it, and then you write the values down, so,
Does that make sense?
Yes, that is right now.
So that is correct. Well, I mean, you can check. If you substitute a 2 in, what should you get out?
How these papers go?
Check that by doing
It
that.
goes-
Parentheses,
Look,
one,
so
raise
It
this.
goes like this, don't it?
yes.
Or do we go?
That was right. Number 2 should be, or number 3. Yeah.
But it's not, you just need to, like,
So,
that's an
um,
important detail. If it's an exponential function, what do you repeatedly do? Multiply, you need to check for 16 again.
Okay, guys, so let's kind of start talking about this idea.
Go 2, 3, 4, 5,
Right,
6,
but
1, 0, 1, 5.
before we get there,
Nobody don't know how to do it.
Alright, hold on.
No, you just
hey
need to
Jay
explain
and
that.
Ryan, y'all look up here real
What is that
quick.
equation?
So,
What is that?
after we translate each point over, how many units? 4 units. What do you notice about the coordinates of the new points? Of the transformed points? Well, what changed in the table?
The egg values.
Okay, so what's the new x value?
2, 3, 4, 5, 6,
Starts with
2.
2, okay, 2.
3, 4, 5.
So how are these x values different from these x values?
Yeah,
Close.
or to the parent functions, x value.
Okay, do y'all see? From here to here, we added 4. But in the equation, it's subtracting 4. So why is it different?
It's opposite.
Okay, do y'all see that? Okay, so if you wanted to get the values in the table first, you need to remember to do that, take that inverse, or use that inverse operation. Okay, so then see, I have the same y values. And let's see what else we got on this one. Horizontally right, okay. Do you have any questions about what you're supposed to be doing on these problems now? Okay, so before you graph anything, figure out what transformations are being applied from the equation. Okay, that's the best advice I can give you to go into this. So y'all continue working on part B, C.
Times 2. So remember, this A and this A are the same. Notice how it's just, we start at A. Right? So the A is where we start. So 1. value of the y-intercept. And for linear, we add b repeatedly, which is why we multiply by x. And exponentially,
Cause again.
we multiply b, which is why it's raised to x. That's my rate of change. This A is the y value of the y-intercept. So what's the y value of the y-intercept? For this number 16?
Well, why not being nosy? Being nosy just feels hurt.
You don't know the y-intercept?
I was looking doing B.
Right. So what is A? So y, so A is.
You got that B over there?
Okay.
B, my rate of change.
Got
What's
the
the
B
rate of
over there?
change here?
Baby.
So times 2.
Oh, no.
Okay, so what's the parent
Look at what
function
you-
for that?
You had the right number.
Second
Right.
equation.
You're saying that we're starting at 2 and then repeatedly multiplying by 3.
Can you
Yeah, be careful. That's a misunderstanding on your part of like what we mean. So that can, okay, definitely makes sense that way as well.
Same point.
Again, so you write down your claims.
I did.
Okay, but make sure you explain it.
Can you have a little,
But also you do have some negative,
two times?
Is it on here?
I meant 2 or 4.
so if it's cubic, it's gonna look like that.
2 or 6.
Yeah, it will, because that's what the 3 tells me, or like kinda how that 2 always, it always makes a parabola. The 3 is always gonna make it into that shape, that cubic shape. And then when you apply transformations, it either shifts it, or stretches it, or compresses it.
No, 2.
What is
But
it?
the,
Y next? That -2
so, okay, so think about what's the equation for the cubic function.
and -13 is the, so.
Okay, so if you want to input an x value of a -2, what would that output y
That
value
means
be?
I want to substitute.
Right, but we have to figure out which ones make this inequality.
You need your
So
calculator.
like, if I look at that first point,
So put
what's gonna take the
-2,
place of
put
y?
-2 cubed in your calculator.
Sure. Which one of those is called y?
Then negative
Right, -13 is that great, yeah.
-2
Oh,
cubed
okay.
in your calculator.
Oh, that's
Okay,
That's apparently you take the inequality true.
it got to be, oh, you just said negative. Okay, so it is negative. Sorry, can everybody make sure that it's negative?
Yo.
Okay, but do you see how you got that? Do you understand how we got that, Chase?
Just kidding, you teach like this, I'll be.
So,
I did teach
How
like
you
this.
going?
I did.
so your next input value could be what?
Well, I mean,
Okay, and -1 cubed is gonna give you
so
what?
-13.
It's not, our points don't go out on them.
Mhm. So, and what's up? Yeah, you just gotta, I'll show
Expand it
you.
a little bit.
Yeah, so like,
Here's -15, right?
Yeah.
Where's -15? So like here's.
so yeah, when I plotted mine, it just
Greater
ended up
means
being
that
a
it's
little
further to the right.
off, but like,
Is -13 to the right of -15? That is what greater than means though. Also, you know you can just use this calculator, right, Joe? If you look above the equal sign, you see there's symbols. Greater than.
okay, so how do you get those new y values?
Well, I mean, it's
Is that
a
what you did each
solution,
one?
but I did say choose all that column.
Yeah.
So we may need more than one. But like, you see how you can just use the calculator to check it out?
I'll be wrong, just calculator.
Look, you can be asking those questions in class, like,
Doing the
we
X's?
literally have a small group to talk
Oh, wait,
with,
what?
and then Miss Courtney and I walk around the room to get
Yes,
this as well.
but you wanna use one to do, you don't want
Dawson, Deborah,
Yeah.
who else is in your group? Destiny,
Eli, you're not gonna talk at all.
that's not true, you can get Eli to talk. Get him to talk. That's your responsibility.
sorry, why did you do 4 cubed and not?
So.
Okay, so your cubic means
Start
not.
having the conversations to get the line, like even if they won't talk, like you have Dawson talking, and you have us to ask questions. Okay? But anyway, when you see
There you
now
go.
know how to do it. We've done that before in class,
When?
beginning of the semester.
That's,
The first, you gotta learn this stuff.
We almost done.
We did,
Yes, we almost, we have like 2
we
months.
did a couple months.
Exactly.
We only been in here for 6 weeks.
We did.
We did the first 2 weeks.
You should call me on Monday.
No.
Oh.
I'm ready for it.
Going up.
We did it for the first 2 weeks, and we took this test on the 5th week.
Hey, why mine
So
don't
it
look
wasn't
like
that
that?
far away. We did it multiple
So what's
times
your,
the first 2 weeks.
what's your -2, where are you supposed to go?
And there was this test that was 2 weeks ago.
Exactly.
But my point is, 2 weeks ago, you should.
Right, the
You call me
-2
a
is
twerk
what's the
baby.
Y value?
Exactly, but my point is that you should have, because we did it in class.
For the parent function?
Okay.
And regardless, did you need
Where's negative 8?
to figure out what that was greater than?
Negative 8's all the way up here?
If you knew what the solution was, you still could have run
Yeah,
points,
we can't go to next
just
door.
like substitute the values in and see
Just act like.
Chill out. Chill out. Chill out.
Sword.
Chase, it'll go off a little bit, but just putting them like this,
That's just stab me.
it's fine. Okay, so did you figure that out? Do you need an eraser? I like a eraser.
You don't have that portion.
Dude, I don't know how I'm supposed to,
It's Kenny with hair.
Alright, guys, kid.
I'm coming.
Who cares about our mental and stuff?
What's up? Were you saying you don't understand something? Don't, look, don't, you don't have to do all that. It doesn't have to be perfect like that.
You can draw a line.
oh, yeah.
That looks nice.
Add a point right here.
Okay, so wait, when we say it's vertical, what direction is we moving vertically?
You're right. This is right.
So like vertically is only talking about up or down, so.
Oh, I mean, he
Yeah, that's
he
a,
told me to write that.
earlier today, someone said horizontally down or something opposite like that.
I need to get a bigger graph.
Yeah.
We'll
but,
update that for the future.
Yeah, it looks good.
We'll-
Yes.
Two more.
What is zero times anything? What is zero multiplied by anything?
Oh, dang, this show gonna be on the,
Lose your head.
this show gonna be on the.
See, that's why I just did my way.
You don't forget.
This was my parent, and then when I moved it up to, I just barely, this one was barely up any
So it's going the
higher.
same way?
It's moved, well, all the points are moving up how many?
Well, so 1, 2.
What? Well, cause look, let's look at the table first. From here, what values are gonna be changing? Right, so that +2 on the outside is gonna change your x values or your y values? Okay, so if you know that, then you can keep all your x values the same and change your y values by that much. And write them first and then graph
What you mean?
That might help you out a little bit. So see how that works out.
Negative one? Oh. Oh.
I did the same thing with.
No.
So I'm just showing you numbers, make it all right. Oh, also Deja, so this is what we did yesterday. Okay, I think, so you're here the day before?
Wanna drive along?
Okay.
One connected. One connected.
Let's see.
That ain't it.
They do it, man. Alright.
So-
Look right there. It's gonna look, it's gonna
Let's look at the table first. Oh, wait.
Come on, Dee.
Well, did you graph this one in red? This is the
You
one.
already done, you want to?
Did you change the colors?
So,
Yeah.
I did.
That's what that one.
let me see how it's. Let me see.
I don't know what this
No,
word is.
that's what you
Ten.
want.
You went up too, right?
Take two.
Hey, we on here.
I did that one first.
The graph this one there in red.
Negative 2 is 8.
Yeah, that's.
Oiler, so it's gonna be -2, okay, this might be where we're messing up. What is -2? Yeah.
So I grabbed.
Okay, so you
One color, you got the other one, other color.
missed the negative in the calculator.
Damn.
I ain't
You did one right.
Hey,
Okay, so right,
but you drawing it, I was
okay, so
like,
now it's gonna be down there.
six, then one,
He's already grabbed that one.
then two, then three, yeah.
No, so the green one is the green that he grabbed. Yeah, huh?
Oh.
Yeah, the green already grabbed it.
No, because the green is at 0.2, so 0.2. That's -1, 0. So where's -1, -1?
That's
Oh, you'll say, no, I was going through it, I had headaches, bro. I was just information.
Yes, what's up?
I get irritated.
Wait, okay, so your cubic, your basic cubic looks like this. So like creating this kind of shape on the graph? Do you have those points plotted?
We started,
Wait.
So where's your parent, can you connect the ones for your parent function first?
Calculated portion.
Yeah, so you draw arrows on the end of those lines, or like the end of them.
Yeah, everybody's been for real before. No random like.
What's the end?
So that's the square root function,
I'm not going to count.
and this is the,
I don't want to do.
I didn't grab blue.
Oh,
I don't want
okay, so what transformation, so you said all the y values changed by 102, so is that how you mark all your dots on here? Okay, yeah, so you can just now connect those together.
I would do what we want.
I don't know, but it's easier to do it like that than.
Yeah, well, we don't got.
So what do you mean, camera keep?
It ain't gonna always stand, baby. Cause how they grab blue.
Yeah, this one, Earl and Steve, this one's gonna be off the graphical. The transformation's
Wait,
gonna
we
be
gotta
off.
do this, we gotta do one.
See, look, she did the same thing I did.
1,
Yeah.
4.
Yeah.
Well, the reason I chose those numbers, remember, is because I'm picking these input values because I can take the square root to give me a nice number for my y.
You gotta make it change or do it like they do. Like you do the other thing you do.
Well, this, so you'll see like, you're gonna dilate it, Cam, so it's gonna get bigger.
What you mean?
When you dilate it on the graph, it's gonna take up more space, I guess, or it's gonna, you know what I'm saying? You'll see.
I'm saying like.
Keep doing what you're doing, and you'll see it after you graph it.
I'm saying like, I know I did.
It was just on my damn white.
You know, the 4 and 2 D's just go on.
Okay, yeah. Okay, yeah. Yeah, so go ahead and y'all finish, AB, keep going, Steve.
Oh.
So we worked a little bit with the square root, yeah. square root function, so remember those numbers you wanna start with. Remember, you don't wanna have negative numbers here on those x values, right, because they're in the square root.
It's still the same.
How you doing, Ryan? You alright?
Good right now.
Okay. What function are you graphing?
I got to do stuff. I forgot to do it.
So, you can just like, go, yeah, trace over them in the color, that's what.
Why?
What's that?
She do something at me. Ow. Ow. She do something at me.
Second grade?
She do something.
Don't look at me in this Courtney station first off, like, grow up, y'all. I don't care.
Okay, so
Yeah,
they
no.
they wanna go right here, right?
Which ones?
They might go.
For the parent functions? Okay, well, that's the parent function for what equation? So they're different, right? Well, you can use,
So you just turn apart.
well, is that what happens?
What, so it's not?
No, it is a square
It's
root.
that.
So I'm saying, it's not the same, you're not using the same.
Oh, okay.
That's what you do, turn apart.
Well, if you remember, we can't use these negative values, because that's talking about, like, we don't wanna start here, we wanna start using with these x's and going on. So what x values would be, like, more reasonable to use with with like having to take the square root of them? I was talking to the fact root.
Go. Thought you want to smoke.
So what you're doing? Also include 1, because you can take the square root of 1, right? What's the square root of 1? Yeah, so that's a valid point we can use. What's up? Oh, no, you're right, and then, yeah, use 4, and then, yeah. I just wanted you to insert the 1 in between those two numbers.
It's like why or something. You got something to lie.
What are you doing? Chill out.
Huh?
I'm holding a leaf there, trying to look at my clipboard, my answer key.
What?
Come on, we can figure this out.
I don't got whole thing get changed.
Huh?
He said,
Things get changed.
Okay, let's look at this. So,
why? Oh, yeah.
okay, so everybody in this group, we're looking at C, right? And y'all have that parent function table? Okay, cool. So how are the x values changing? Okay, so all the x values are moving to the left 3 times, so how can I calculate that from here? Do I need to do 0 plus 3 or 0 minus 3? Okay, so can I subtract 3 from these x values to get my new x values?
I was thinking that, I was like, but this is gonna be, it's more than 0 though.
That's true, that's true.
That's all I have.
You just kind of 2 periods or something to get the help.
You're looking at the wrong one.
I don't know.
You trying to,
You can start doing better than you. It's not pretty.
Yeah, I know. Cause I was here on the start of this, so yeah, I'm caught up. Not this.
You gotta get your color on this too.
Yeah.
I really can, I can
Okay.
get some water real
so
quick.
Next
now,
week, when you start coming
how are those
to.
y's changing, Cam?
Miss Keck, I go get some
How
water.
are those y values changing?
Oh, Miss Courtney,
Are they going down?
I get some water real quick.
Tutoring next week.
Oh.
Sorry, I'm here asking these questions, 'cause I was having to listen.
I need y'all to
Let-
elaborate.
How, let me ask y'all, how are the y values gonna change? What do we need to do to them?
They're doing some by So we got two major.
Okay, so what's that negative?
This is for.
So that negative is multiplying
That's what I'm-
by this main operation.
Wait, it looks like you did, you took
So
this
that means I have
negative
to,
two.
since it's
That
on
was
the
a
outside, I
downside.
have to multiply my y values by
But if I
negative two
have
to get
two-
my new ones.
Times three,
Okay.
times six. And I'm gonna do, is I'm gonna give 6 times 4.
No,
I know
don't
the
don't
graphical
square
card
it
is
out.
Six.
super graphic, it's gonna go like this. It's gonna.
Or what's your like?
You grab one like that? Where you get 12?
I'm talking, no, you're graphing.
You don't have to take it
Well,
out.
because
You
two
just
times
move
three
it
is six.
out.
Because
Six
this
is 12.
part,
Oh.
or the x minus 3 is just
Okay.
saying every x value you do it over 3, but remember
So
that
it's
square
that
root just
negative two,
maintains
also
the
it's
shape of the
gonna be
entire
multiplied by
graph.
No,
Okay, so for the
but also, so that's one.
So for the y
The second issue is
values,
this. You need to recognize that it's x minus
so
2
from
times
this equation,
x
what's gonna
minus
change
6.
the
So
y
if you were to multiply, you need to distribute
on
like
the
this.
outside, right? So negative
Yeah,
2,
distribute.
what operation?
We're gonna have a unit where we look at this more heavily, that's what you should have actually got.
We don't have to do times the square root of anything,
But
you
that's
can
not
have
what
a
I'm
negative
saying.
2 times all of the
That's
y
not what I'm
values. Yeah,
Hey, send me a teacher, you should.
Right here.
To write it first.
what did you multiply that
So
with?
you're closer with this.
Okay,
But
yeah.
that's not vertex form, that's it.
Okay, you gotta do 0 times
And you got there, the
negative
vertex is 4 coming, so
1
why
times
did you do
negative
this?
2 is negative
A,
2, you're
is
doing
negative
these
two.
y values. You have to
And you
multiply
can
by
just
y
take this
values.
x minus
Toes
the
going
h.
around, so.
Does that make sense to you?
Hold on,
What is
man.
the h?
Give up.
You made that harder than it had to be. Look, you literally wrote out this equation, right? And then you wrote it kind of like that.
About how you all your mind.
Except
Why
if
didn't
we
you
graph
even
any
identify your h and
negatives,
k? Why didn't you
any
just
negative
substitute
x
here?
values, can you take the square root of a negative?
You made that.
So, right, but I'm saying, like the,
So I got you right. So you started
wait, no,
with
no, no,
Vertex
don't, or,
So how are you gonna get the, so if you want factored form, what do you need?
let me make sure you have the right points in your table. I didn't do that, I was looking at your.
But like there's this was in factored form, it gave me roots, and I needed the vertex, so use the calculator. You don't have the.
So it is 0.
You multiplied, we're multiplying the y values by negative 2 to get the new y
I
values.
had started multiplying.
You
No.
multiplied the x values. Okay, so fix that, Cam, and see if that fixes the shape of your graph.
Okay.
I'm in love with that.
I'm trying to change what the people.
I'm in love with the shape of it.
Can I see that?
Yeah.
You can't go that far. Just do it.
You're around it, too.
They just went up,
Just really important.
all the way up.
Can I see that thing?
You got this way.
Can you draw my?
Oh, I do.
That's good.
Okay.
I don't know what you're talking about, until you tell.
Keep that.
Oh, you definitely need that too, but that's actually not something. Then you have a function right here.
Okay, James, yeah.
Isn't this a function? Is
That's the work.
it a function? No, you remember, I need you to remember, a function needs both inputs and outputs.
Come here.
Because what you've written right now, I have both an input and an output. Right here, this is a function.
Let's look at your table.
Oh.
Okay, everything moved down by 3.
Because I wanted you to think about
That's
it.
not consistent with what happened. So this was minus 3, this was minus 3, this was minus 3. That was
No, I expected you to think and you didn't even
But
think.
then the y
I
value,
knew what you were talking
about, but I didn't know what you were talking about.
right?
But did I tell you what I was talking about? Did I? No, I
So
said
you
look here.
multiplied, let's see,
Did I? What did I tell you? To look
You
at,
did
did I tell
negative
you
two
that you
times,
were
so
just function notation?
I'm looking at the.
Oh, that was it, we don't have to figure around it, I was asking you what did you miss?
So-
You still had to think more about me doing.
I think you had the right idea,
Just told
you
you,
just
hey, you can
mix up the values you're multiplying by. So you know you have to multiply by this negative,
To have a
right?
function, I need
Okay,
to
so we have to
and-
multiply these y values by that.
So that, I could also put y if I wanted
Because
to.
that's how the y values are changing. When it's like,
So
how are the
zero-
y values changing? They're being multiplied by a -2 because the negative's on the outside.
We gotta multiply these by 2.
By a -2, because you have a negative out on the front. Does that make sense, Jay?
To get the,
So,
yes, you'll need to type that.
yeah.
Do you need the vertex for those?
And then so all your x values,
Stay the same, right?
look how these, so what's changing about the x will be inside. Okay, so what do you have to do? You have to do something else. You have to subtract.
So, what, -3.
That's the parent function. No, that's the parent function. That looks okay. No, yes, yeah, that looks fine. That 16, don't worry about it.
Okay.
You'll have enough on there.
And be a time.
Wait, come here, come on.
Oh, Mom, you crazy. Oh, Mom.
Wait, come, wait, I need
So the x
Yo.
So you're doing subtracting from these x values. Remember, so you did 0 minus 3, and 1 minus 3.
Yeah, the hold though.
She's like it.
Yes, both, actually, right? Because you were saying, okay, so you got all, because of the multiplication, it's gonna be dilating, but also because of the negative, it's
So
gonna
this
be,
the parent function, this one, right?
the parent function,
Another word for.
no, because look, your parent function 0, 0, 1, 1,
Remember,
4, 2.
an x intercept, or 1 comma 0. So they're also called.
Do what?
Why you say that?
I think,
No. You do freeze.
what is this?
Damn, I'm at the man.
Bro, I knew you weren't doing it right, bro. What?
You told her doing something.
Why does it have an arrow like that?
I need to actually check this.
Okay, so it doesn't go back up. It
I'll
just,
see you Tuesday morning.
it just kind of,
Oh, you go, yeah.
it just goes that way.
I did it, do the,
Yeah, so you will have to, things to talk about the inverse there, before you do that, what's the parent function? Okay,
Okay, so this is right.
She said,
I'm sorry.
no.
You probably
I don't know that.
It's getting annoying. That's why I would never get to.
The standard form. Right, ax squared plus bx plus c. So what's your?
So then I just gotta write that.
I'm gonna give me a job. I'm bored.
yeah, graph the transform. Oh, but also notice how like it doesn't kind of curve back up like that?
I did it because it was off the paper.
Ooh, some old.
Okay.
I could write it, it doesn't curve.
I mean, honestly, I just stopped mine, like, kind of showing that it's going in that direction.
Oh, so I have to do all the
Oh, shit.
I would keep the 9, 3, and draw an arrow going this way and erase that top part.
You gotta make it big, like, what you want?
Yeah.
Like big.
I did it so wrong.
Don't get on burrito, don't get the frame.
I might go give me a burrito.
He talking about
They got steak.
They ain't got no cameras in there.
They got steak.
Hey.
They just still like to say.
Time to go.
That's why I quit. Cause I wasn't it wasn't coming out my cheek.
And
I was gonna try to subtract it out my cheek and try to divide it between everybody.
Okay, so look at the parent function. What does that graph the absolute value look similar to? Which one of those does it look most similar to? What about like just the shape?
quadratic.
Okay, so thinking about, can we use similar x values that we use for the
The
quadratic?
burrito is too high.
Look at absolute value on shapes?
Look
Look at the absolute value.
Shake, shake.
Yeah,
I
do.
don't think y'all got that down here.
No, we do start at zero.
Here, Shake Shack, right?
Food, no food.
That don't have that.
We started at nigga two.
So you not even look at
I'm
the
saying,
Right, yeah,
yeah,
I'm trying to know.
they true.
Look at this.
This
guy- this-
It look like a quadratic, nigga.
You see how these look similar in shape? I'm saying you can use similar x values that you used in your
So
quadratic
it's, so
table
for the points going down,
to
it's
to
negative
figure that out, right?
Free,
We got
long live, keep
negative
healthy,
2,
man.
1.
Free live,
Oh,
who?
goddamn, negative 3, 0.
Coffee bill class.
So you G.
Negative 3, 0.
That one got the magic.
Negative 2, yeah.
You
1,
help
4.
me, asshole, right?
Okay.
So do you
understand that about the x values? Using similar x values that we used for the quadratic function?
Free air taco.
Yeah, you can just check on that.
Free air taco. Real. The fan where you can right here. Free braids and honeycomb.
Well, you know.
I don't even think about
I know, but you say
Okay, so then, so what are your output values gonna be
I
for
will
the
say
absolute
Monday will
value?
feel the help to take this class.
I don't even figure that. Oh,
won't be here, so.
What's the absolute value?
oh,
of negative two?
absolutely.
Can I go to the bathroom?
Yeah, you can go to the bathroom.
Yeah, I can.
Just be productive. Or, yeah, because I don't want her to say absolute
What's up?
value.
So what's the absolute value of negative two?
You learning from your mistakes? That's the goal.
And then,
Right, I do love.
I'm trying to get A in the worst class. I know it can be no A's.
well, so just to remember, taking the absolute value of it doesn't change the Okay, so after y'all get
All the medicine.
that parent function, what transformations have been applied in that equation?
Hey Siri.
So you're very infinite, that don't give us,
I did it one time.
reciprocate, right?
See how your line.
Yeah, like,
Let me see the time thing.
times, most right by two.
All just make sure line
So,
is
it is
all the way
right by
down
two.
here.
Yes.
Yeah.
Okay, so, well, you're still, okay, so you're doing the change in the y values, that's cool. So then, what are you gonna do with that, that two? Well, what operation is it gonna be?
Wait, right now?
What we gonna do to the Y?
No, think about, no, sorry, hold on again. Think about, it's not, yes, it's multiple, it's multiple. Yes, which means we gotta do
That's
what?
what you trying to do. You don't want me multiple. I can joke.
Yeah. What? Oh, I was just,
Why ain't even talking?
They you encouraging him. Stop making him be for you.
Just can you come here?
You encouraging him.
No. You stop.
You
You start out with a lie, now you're just lying. Just word.
how do the y values change from this equation?
Yeah,
We gonna worry about.
What? Oh, okay, so what do you have to do to each y
Hell
value?
no, we gonna be
Everybody get.
Yes,
get out for that.
that first one? Okay,
Bro, we team up, bro. We need to team up with somebody. We need to team up with like
Stops.
Germany.
And it's not flat.
I thought we was with.
I thought we were,
Damn.
I ain't gonna count. I will truth the truth though. That's what they say. That's what they say we're a powerhouse. But Russia is true. Russia, God.
do what?
That don't kill.
They be whipping this and double person. Oh, no, Russo flesh.
one day.
You now working so hard.
What the heck?
I'm not
It's
doing
not
that.
cheating, bro. Cheating never wins, dude.
Don't look no like the race. If I gotta race them longer. No, I very well believe.
Long as you let them go.
Do you need to be careful of our functions? Like, this isn't gonna curve back up like that. It looks like that because you're running out of points. It's just gonna be flat. It's gonna, not flatten out, but it's gonna go smoothly out like that. What I would point out is, you see how this,
do work more
it's gonna keep going up, right?
Yeah.
But it's going to the right a little bit.
I feel like it's kind of different. We like do a whole lot of rest. We don't got time.
Y'all know you're supposed to be justifying on this too, right?
Yes, sir.
Okay.
Yes, sir.
Huh?
What do you mean, huh? Do you wanna be ready for understanding checks and tests?
When we got done to understand shit.
Next week?
Look, it's different.
But you see how this is going up?
What's up?
But it's gonna keep
Here,
going
these
to
words
the
you can
right.
turn in for grade.
Okay.
They don't.
This is a very similar thing,
I mean,
but
but if
it's
you
almost
look-
the
whenever we go
inverse
over
where it's gonna
together,
keep going slightly up, but it's going really far out. But you see how like, this effectively is just half of a parabola going sideways. Does that shape make more sense now? We'll talk about why it's only half later, but that's
You
me
better talk about
talking
these.
what a square root is. So be careful of that graph. Okay, you think so? Make sure you justify. Make sure people in the group understand it too.
Yeah, bro. Make sure we understand it, bro.
Hold on, I gotta make sure I have it.
Oh, I'll wait.
I said it, I'm over. You, you, they could. This week? I don't care if you know.
How you wanna do
You was not making it happen, okay.
I'm not doing that. Them motivation. Trying to degree.
Happy birthday, Miss Courtney.
What?
It is not number.
No.
What would you do?
Okay, if it's your birthday, we're
What's
gonna
your
go
start
over.
off with? I think your birthday paid.
It's your birthday in March.
You talking about he would
Oh,
roll.
okay. Happy early birthday.
He was sharp.
I think birthday.
See, I'm a real student. See, look, I had said your birthday in March. I said, I knew your birthday.
You said when was his birthday?
No, I said, is it in March?
I'd be happier if you knew the math really well,
Oh,
but
good
yeah.
thing. You go back
Man,
to
you
the
can't.
Hey, you see me over here though. You see me over here though. You ain't looking.
That's why I like bitch kids like real shit.
Academic.
Imagine seeing him
A, B, C,
outside
or
of
D.
school.
This one, see.
They're like, hey Ryan, how you doing, man? Man,
Started
think about that. Big kid like real stuff. Like I like you, man. Like you cool. Like real talk.
Charles.
Like you can joke and stuff. Well, you be serious though. You know.
Yeah, he like he got
Like no teacher got what you got for real.
he got like a 2% sense of humor to do it. It be still work though. I don't know, green teacher.
Hold on.
They recorded this video.
Hold on.
Okay, guys.
Alright.
So, can I get y'all's attention, please? Okay, so kind of what I put up here so far for us to work with is this parent function table, and I went ahead and graphed what that looks like because we really need to talk about these transformations from the equation to make sure we understand how to make the transform table. Okay, does everyone see what I'm talking about? Okay, so Cam, can you tell me how my x values are going to be affected from this transformation?
The h is being added by 3 inside of the equation main operation.
Okay, so what kind of transformations happening?
Horizontal translations of 3 units.
Okay, a horizontal translation left 3 units. So if I'm going to the left 3 units, what do I need to do to these x values?